Now into what I think is the fun stuff, because this is some new products from HBK that I think are going to help eliminate a lot of these issues, even if you can't, especially if you're limited in space, especially if you're limited in your cable routing. So let's review. What are the effects of our interference? What are the dependencies? Voltage level, current level, frequency of the inverter. Those aren't going away. Unfortunately, those are from the engineers. But parallel paths, distance, and shielding are things we can affect. And we have to ask ourselves, what if we eliminate copper from our measurement? And that's where this whole fiber optic idea comes in. Because if we eliminate this copper, we eliminate all these couplings. And when we eliminate the couplings, we eliminate noise. So kind of coming to this super practical, this is an ideal power analyzer setup today. You know, we got our battery, inverter, motor, gearbox, transmission, load, whatever it is. We got our current sensors. We got 4 cables coming to a CT power supply and 4 more cables coming to a power analyzer. So we got 8 cables. I'm in Japan right now, so it's 8. We have 4 voltage cables and, torque and a speed. And in the ideal setting, this is still a lot of cables. But in reality, we have setups that look like this. We've got, this nightmare. We've got unshielded things everywhere. We've got just stuff lying on top of each other, next to each other, loops of cable. This is the reality we deal with. So we go back to the screen, 12 cables. We got 12 cables of voltage and current, 2 more of torque and speed. Well, we have high voltages too. We have to consider these voltages are going higher. We have high voltage safety issues. High voltage can potentially come back to the automation system, come back to the control room. So we got high voltage. So you want to make sure your stuff's cat rated appropriately. It's not the topic of today, but it's also important because safety is a factor too. We have EMC issues. These high voltages and these currents are right next to each other. They're right next to the inverter lines. We have EMC issues up here. Now, this is a low, or a low voltage, low current cable. You have a lot of potential for signal to noise, and that's coming in right next to a high voltage or a high current. And this isn't just HBK. This is every instrument you're ever going to touch. Another view of that same test setup. High voltage is coming in, long cables. These cables can potentially be quite long, a couple meters. We have long 8 cables coming from our current sensor to our power supply to our power analyzer. And a lot of potential for noise. So here's our proposal. And here's the new product we're coming out with. We call them the fiber optic probes. We're going to have a box that sits right next to the measurement. This box is going to measure voltages, my box on top, or currents, my box on the bottom. And it's going to sit right next to the measurement. You're still going to have a copper measurement cable, but it could be 10, 20 centimeters, really short. We shorten that cable. We shorten that inductance. We shorten those parallel paths. We shorten those loop paths. We shorten all of this stuff. 10 centimeters, not much room for noise. We lower that L. We lower that C. We lower that induced noise. We digitize the signal out here and we send it back fiber optically. Same goes for the current. 10 centimeter current cable. We're now going to offer that power supply inside of the fiber probe. So we're going to do the excitation locally. Now, instead of 8 cables, we got 4 cables. Short, low L, low C, low induced noise. Boom, fiber optic. And once it's fiber optic, it's light. There's no copper. Remember my point about eliminating copper? Gone. Really clean measurement. What are the benefits of this? Well, uncompromised safety. You no longer have high voltages coming back to your control room. And if you really look at it, safety is the most important thing. HBK is all about safety. We have a safety briefing every day. So, safe, this is going to be as safe as it gets. No high voltages coming back. Minimize EMC. You reduce your inductance, reduce your capacitance, reduce your parallel paths, reduce your loops, reduce your EMI, EMC conduction in your measurement. Shorter cables prevent reflections. You actually get a higher quality measurement because you're now transmission line physics. You're getting rid of a lot of that because you have a very short cable. At the high inverter switching, at the high DIDT, this is real. I'm sure there's some guys from a certain automotive company who I've worked with who are going to be very elated because we've seen reflections in their measurements. And there's nothing we can do because it's in the cable. I mean, that's in the measurement cable, except make it shorter. Integrated CTs to minimize the amount of cabling. Fewer cables, less noise. That one's pretty straightforward. And because it's fiber optic, it's all light, we can put these up to 50 meters apart. Now, if you've got a test cell where you've got things really spread out, we can really spread things out. Multiple motors. I think of the aerospace guys who have stuff all over. This is a really, really exciting technology. So my old setup, lots of safety, lots of EMC. Still there. It's not completely eliminated, but we've shortened those cables. We've eliminated cables. We've made this a lot safer and better from an electrical noise standpoint for measurement. You know, you're just making your measurements better. So some of the tech specs, the remote voltage probe, five voltage ranges up to 2 kV for those ever increasing voltages. And these are going to be available in 2 megasample and 20 megasample variants. So we can actually go to a higher sample rate for some internal technical reasons as well. If you want to start looking at some of those more detailed switches, to be honest with you, for power, you don't need much above a megasample. But if you feel that you do, that option's there. Current. We're going to have 6 current ranges up to plus or minus 2 amps. Again, 2 or 20 megasamples. And we're going to have an option with a built-in current power supply to simplify that cabling. And the last one's just our internal card. This is for bringing in the measurements. But, you know, 4 voltage measurements, 4 current measurements. It's going to be a really sweet setup. 2 cables, 2 fiber optic cables. So just from the simplicity standpoint, it's going to simplify things a lot as well.